lessons 5.3 and 5.5, we're going to be proving triangles congruent today. So our first way we are going to prove the triangle congruent will be SSS, side-side congruent theorem. So if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So in our picture, we said AB. If AB is congruent to DE, and BC is congruent to F, and AC is congruent to F, that means the triangles are congruent. So I could say triangle ABC is congruent to triangle DEF. So sometimes the triangles are going to be drawn separately like this, sometimes it's going to be up against each other. And that's what it's going to look like in our next one. So here we are given KL is congruent to NL and KM is congruent to NM. I already see that second one here on my given to that, which means I haven't included my first given yet, so I'm going to include that. Segment KL is congruent to segment NM. So what I see in my next step is that LM, segment L1, is congruent to segment LM. And that's the same segment. So what I would call this is my reflective or shared side. If both triangles have a side in common, I could say that side is congruent to itself as a reflective property. And now that is my third side that I said is congruent. So I have enough information to say that triangle KLM is congruent to triangle NLM, and that's by SSS for side, side, side. So you're going to determine whether the congruent statement is true. So determine if the triangles are congruent and make sure that the letters match in the right way, and explain your reasoning. Pause, and when you're ready to see the answer, hit play. So number one is yes. We see all three pairs of sides are marked as congruent, so that is side, side, side. And if I look at my congruent statement, D matches with H, F matches with J, and G matches with K. For number two is not true because AB is not congruent to CD. Right? One is 3 and one is 4. So these triangles are not congruent. Number three is yes. I see three pairs of marked sides that are congruent. And then I could see that Q matches with R, P with S, and T with T. The second one is two triangles congruent. Something called SAS. And this is very specific side and side. In this order, because they have two sides, and between them is the angle. So when I'm looking at the sides that are not congruent in our picture, between them, next to them, it makes the angle that is congruent. So that is very important to order that. So if we knew, if AB is congruent to BE, and angle B is angle B, and I knew BC is congruent to F, now I could say that triangle ABC is congruent to triangle BDF. All right. If this angle is not between them, say it was over here, there's an S here, an S here, the A is here, that means this A is not between those two S's and it does not count as SAS. So in this proof, we have BC congruent to BA and BC parallel to BB. So we're going to do all of that in our first one again. BC is congruent to BA ABC is parallel. So just because it's congruent doesn't mean it's parallel. In this case, it does have to be one. Right? And then whenever I have parallel lines, I should have one conclusion. I'm going to have all the interior angles here. So if I were to connect the parallel lines and also, then I have an alternate interior angle. So this is the angle BCA is congruent to angle BAC. So now I have that AC is congruent to CA. So my answer is this line that's shared by both. And anytime we have a shared side, that is a reflected side. So now I have in my picture, take a look at this. We have a side and a side, and here is an angle. If I connect the two sides, it points to the angle. So that is SAS. For how triangle ABC is congruent to triangle BBA. So we're going to look at all four of these problems. We're going to determine, is it possible to say that they are congruent either by SSS or SAS? If they are, we're going to write a congruency statement. So for number one, I'm going to label my S's and my A's, my S's and my A's. And this triangle, if I follow the order below, SAS and SAS. So they're all congruent by SAS. And now for a congruent statement, I'm going to say QYC is congruent to, the Q is on the side that's on there, Q is on the side that's on there, C, J, P. For my next one, I have this reflective shared side that I can knock off. And now I have an S, an S, and an S. And the same thing in the other one. So this is SSS. I can say triangle ABC is congruent to, so AD with the star with one dash, CD with the star with one dash, CBS. Number three is a tricky one because they overlap. I do have the sign SK in both triangles, so I can mark that as congruent. I'm going to redraw at least one of them, if not both. So this is triangle JMK. This whole angle here is one. We have one dash here, and we added the reflective side there. So looking at what I have marked here, that's a side, and angle. And the angle is between two sides. So we could say this is SAS, triangle JMK is congruent to triangle LA. And in number four, we have a side that's marked, and an angle that's marked. If I connect the two congruent sides, it points to angle S over here, not triangle SUV. So this is not possible, right? What it looks like instead of SAS is SSA, and that's not allowed, right? Because the other way around would be ASS, also not allowed. So not possible for number four because the A was not between the S's. So you guys try these two, pause, hit play when you're ready to see your answer. So for number one, it is congruent by SAS. If I looked here, I also have SAS, so they match. So that would be triangle RTS is congruent to triangle UST. And then in number two, looking at the triangle on the left, My two S's are here, and my A, which is a vertical angle, is over here. We're allowed to mark vertical angles as well. So now I don't have SAS because the A is outside of the S's, so this is not possible. Even though it didn't look like SAS in the other one, right? It didn't match the both triangles, so it's not. We're talking about that's not possible. So ASS does not work, right? But there is a very specific case where it does, but it's called something completely different. So in a right triangle, the sides adjacent to the right angle are called the legs, and the side opposite the right angle is called the hypotenuse. So we have something called hypotenuse-leg, or HL. So if the hypotenuse and the leg on the right triangle are congruent, then the triangles are congruent by HL. So here, if the hypotenuse BC was congruent to EF, and L, right? Either AB and EE or AC and EF, which are marked in red. This is AB is congruent to BE. Then I can say that triangle ABC is congruent to triangle DEF. So if I'm going to use HL in a proof, since it only works in right triangles, I have to state that they are right triangles if I plan to use it. So if I'm given right triangles, I know I can now use HL. It's giving me also that ML here is congruent to MN here. I have a reflected or shared side in the picture. So I can say that MC is congruent to MC. And since they're right triangles and I have the hypotenuse congruent and a leg congruent, I can say that triangle LMP is congruent to triangle NMP by HL. So we're going to redraw triangle ABC and DCB side by side. Corresponding person in the same position. So I'm going to keep triangle BCD the way it is, because I'm used to seeing right triangles. So B, C, D, that mark there, and we technically knew this was right. So when I go to redraw triangle ABC, we should have the same marking. So B is at the top, A is on the outside. A is on the outside, B is on the top, and then B is where the right angle is. And this looks good. So you're going to try these three. Is it HL, SAS, or not possible? So give these three a try, pause, and when you're ready to see the answers, hit play. All right, so for the first one, we see we have SAS on both triangles, where the A is between the S's. So even though it was a right angle, it doesn't automatically make it HL. That's still a congruent angle. So number one was SAS. Number two was not possible because we look at SSA and it's not a right triangle. If I get SSA, I can look to see if it's a right triangle, and if it is, it's HL. If it's not possible. Number three also looked like SSA, but it was a right triangle. So that is possible using HL, hypotenuse-leg. And if I look at my picture, I would have had the hypotenuse here and the leg here. All right, a little bit more practice with some proofs. So we're given that segment AC is congruent to segment BC. And we're given that angle ABC is congruent. Oh, I'm sorry. And angle ABC are right angle. I have that marker ready for us. So now that I know we have right angles, I can solve them for right by the right angle congruence theorem. We talked about it very briefly, so I'll quick. I also have an extension using the reflection property, CV, congruent to CV. And it looks like I'm actually missing a step here. So I want to use HL to say that these are congruent to each other. I'm going to have another step here, and triangle ABC are right triangles. And that's what we see by the definition of a right triangle. Because what it means to be a right triangle is that it has right angles. And now in my next step, I can say triangle ABC is congruent to triangle ABC. And that is by HL. All right, so our next one, we are given that WX bisects the angle VXY. So what it means to bisect an angle, two congruent pieces. So definition of angle bisection, we can say that angle VXV is congruent to angle YXV. We're also given that segment VX is congruent to segment YX. We can use the reflexive property in our picture to say that XV is congruent to XV. And now we have enough to say, using SAS, that triangle VXV is congruent to angle YXV. All right, you can go ahead and try this last proof, pause, and when you're ready to see the answers, hit play. All right, let's check this last one. We were given that the lines were parallel. It's these two lines that are parallel, and I connected them. The angles that I made are here and here, so that's angle QPR is congruent to angle SRP by the alternate interior angle theorem. I was also given that segment PQ is congruent to segment RS. I could use the reflexive property to say that that shared side in the middle, PR, was congruent to itself. And then I have enough information to say the triangles are congruent by SAS. And that is sections 5.3 and 5.5.